how water temperature affects RO performance. So as we go into winter, you will notice that the ground temperature, the ambient temperature goes down first, then slowly the ground temperature goes down. And at some point, that means that the temperature of the water that's being fed to your reverse osmosis system will also be going down. Now, at 75 degrees Fahrenheit, 25 degrees Celsius, this kind of mark here is the maximum performance of an RO, this temperature. And the thing which you have to remember is that at 4 degrees Celsius or 39 degrees Fahrenheit, then the performance of an RO will be half of the performance of it at the higher temperature. So, and it's linear, so it's a straight line between the two. So what that means is that as the ground gets colder, your source water will become colder, the viscosity or the thickness of the source water will become thicker, like more viscous, and then eventually it turns to ice.
Yeah. That's why it's like if you put water in a glass and put it outside, it will crack because it expands, right? No?
Yeah, not in a glass. It has to be in a sealed container. Yeah. If the glass is, it'll just go up. Yeah, okay. Yeah. So this is the thing to notice is that the water will become like thicker, if you want to imagine it like that, more like a gel. It doesn't turn into a gel, but if you imagine that a gel is thicker than water. So we don't notice that it's getting thicker, but it's getting thicker. And then that when you're trying to push the water through these tiny little holes, that viscosity makes a difference, and it doesn't get any worse than at 4 degrees, right? So 4 degrees is or 39 degrees Fahrenheit, that's your critical mark of the worst performance of an RO. Now, a lot of the guys cleaning from fall through to winter, even though the ambient temperature of the air is dropping, the ground temperature is still relatively warm, so you don't notice it so much. However, at the other side of winter, when the ambient temperature is going up and you've got a lovely day, the ground is still potentially 6 feet deep as frozen. So you've still got very, very cold water going into your RO, and then you'll think, oh my God, my RO doesn't work as well as it did when I went into winter. So maybe there's something wrong with my RO. And we've seen over the years, a lot of people replace their ROs on advice on the basis that they've fouled over winter and stuff like that. And it's actually really, really unlikely that they've fouled over winter. The most likely thing is that you're dealing with really cold water, and so the performance is half. So again, if you're coming out of winter and your RO is not producing the same flow rate that you were experiencing going into winter, then you would want to possibly look again into the tractorsupply.com or TTI or sylvan.com.au, like places, the agricultural suppliers of tanks, and buy a tank with a 12-volt pump. It can be 60 PSI through to 100 PSI, preferably 1.7 gallons per minute or 7 liters per minute, something like that. And then that little pump there will handle all of the back pressure while your RO is delivering, less, but the maximum that it can do. And then if you want to boost the pressure going in, then you would put a booster pump like a Wayne PC4 or a Liberty 331 or equivalent half horsepower pump used as a transfer pump mostly is the basic design. And you can put this pump in front of the RO and increase the pressure in front of the RO so you've got more pressure to create a bigger pressure differential across the RO. How did that go? Did I say that good, Martin? I think that was pretty very clear. Whew, good. Wow.
I understood it.
Great. Well, if you understood it.
The colder it is, the harder to pass through the RO.
Yeah.
Basically.
That's basically it.
Yeah. So you can use a booster pump, for example?
Yeah, you use a booster pump in front of the RO or a buffer tank and a delivery pump after the RO. Yeah.
Yeah, because then you know the temperature.
Yes.
You can control the temperature.
No, not the temperature. You can just offset the effect of the temperature. By increasing more pressure means you'll get more product. Yeah.
Okay.
Yeah, even though it's thicker. You won't get the same product. You'll just get, or the same production rate, you'll just get more production because you've got more pressure differential across the membrane.
But it also affects the glass, right? The temperature. How you clean it? Maybe that's a different topic.
Yeah, it's a different topic, and I don't know there's a lot of evidence that the water temperature actually changes, because clean is clean, and we've got no problems, guys, cleaning windows. So anybody who says you can clean windows better than clean is maybe mythical.
Yeah. But you're still using zero TDS. So it's not
Yeah,
getting any
yeah.
water anyway.
No, so your spot-free result is going to be spot-free anything under TDS 10. So TDS 0 is not critical. TDS below 0 in the parts per billion is definitely pointless. And so the most important thing is to choose the right brush and or the right scrub on a brush so that you can get the debris off the glass. If it's difficult to remove with bristles, then you need to get the debris off the glass. And so that's why your brush design and your rinse function, like agitate on the upstroke, rinse on the downstroke, that's your efficiency.
The scrubs, it's the radial rocker, it's the deep frame rocker,
Deep frame rocker.
windows, and our new solar rocker as well.
Yes. They're all rockers with good scrubs.
And always
All right.
wear the glass.
Always square on the glass. I like
Okay.
it.